I'm going to do problem number 31, section 4.7. So 4.7, number 31. We do have a right circular cylinder that is inscribed in a sphere of radius r. So let's say this is sphere, and so we do have a right cylinder that is going to be inscribed inside of this. Find the largest possible volume. Largest possible volume. So one thing is interesting here is that there's no way for us to find the smallest possible volume, because what happens is that you can just close this cylinder, make it smaller and smaller and smaller, smaller, and eventually you get to have a line. And as you know, in mathematics, line doesn't have area, and when both lines coincide, they don't have area, and therefore there's no volume. So I'm glad that the problem is asking that, to find the largest possible volume. And so let's see what can we get to help us here. We know that this sphere has a center somewhere here, and of course, let's say that from there we can, no matter where you have this cylinder, you can have a right triangle. Okay. And since we are going to be taking the derivative, let's, instead of usually call this horizontally x and y, I remember this problem sort of, it works better if we call this vertical part right here x, and this horizontal y, and let's call this r for radius. It is essential to remember that no matter where this cylinder is, how tiny or how far you pull it to the sides, the radius remains to be constant, no matter. So let's say, for example, if you have another one like in here, notice that this radius is here, still is the distance from the center of the circle to the outer rim. So the radius is a constant. So therefore, when you take the derivative of a constant, it becomes 0. Let me go to the next page. What is it that we have according to that page? We know that the x squared plus y squared equals to r to the second. And here I can solve for y and claim that y squared equals to r squared minus x squared. And I'm going to keep this handy for my substitution. What is it that we know about the volume of a right cylinder? We know that the volume as a function of x equals to, okay, pi or the area of the bottom of the cylinder, okay, which is going to be pi r squared, which is pi, in this case, y squared, times the height. Okay, what's the height of a cylinder? It's going to be 2x, because remember, x is from the bottom of our triangle to the base of the cylinder to the middle of the circle. And now that I know what my y squared is, I'm going to go ahead and substitute and say volume as a function of x equals to pi. We know y squared, we have it in here, is r to the second minus x to the second times 2x. And of course, we should remember that the radius x or, the x of the, the radius of the bottom of our cylinder can go as small as 0, just make it nothing, and go as big as r. So that's the constraint for this problem. Now I'm going to go to the next page and take the v prime. Now I know v prime as a function of x equals to, I'm going to keep the 2 pi out, it's my constant. Derivative of r to the second minus x to the second. Oh, let's do one baby step actually. Before taking the derivative, let's simplify that and say that volume as a function of x equals to 2x times r squared times pi. It's going to give me, here's my 2 pi, then I have r squared x minus 2x times x squared. I have the 2 out, so this becomes x cubed. And v prime equals, v prime of x equals, so here's my 2 pi. Okay. Derivative of the first part, so remember that r is a constant, therefore r squared is a constant. So b is only r squared minus 3x to the second. Okay, set that equal to 0. So this gives me r squared equals 3x to the second. And this follows that x squared equals to r to the second over 3. And of course, x equals to plus and minus r over square root of 3. And we are going to just trash the negative part, since this is geometry and I cannot have a negative x. So x equals to r over square root of 3. So this is the only critical point. And I know that, I do have a maximum at this point, because as we showed, we cannot have a minimum. So at x equals to r over square root of 3, we have a maximum. Okay. And we know that what is v volume of r over root 3 equals to 2 pi r to the second r over square root of 3 minus r over root 3, and that this part was cubed. And that equals to, let me change color to, here's my 2 pi. I have r cubed over square root of 3 minus r cubed over 3 root 3. Need LCD. Going to go to the next page. And so I have volume of v over root 3 equals to 2 pi 3 root cubed over 3 root 3 minus root cubed over 3 root 3. And that equals, here's my 2 pi. That gives me 2 r cubed over 3 root 3. And if I do one more simplification, 2 times 2 gives me 4. Here's my pi. Here's my r cubed over 3 root 3. Okay, I hope you enjoyed this example. Thanks.